Any issues in gradient, tangents and normals? We also touched this topic, increasing and decreasing functions, and the extent of it was, if the gradient is positive, the function is increasing. If the gradient or dy by dx is negative, the function is decreasing. Stationary point known as turning point. The gradient at turning point or stationary point is 0. Let me show you graphically. And exercise 12I. If you just consider this sketch of a cubic graph. At this point on the right of this turning point, the gradient is positive. On the points tangent to left of this is negative, and from negative to positive, whenever you pass from negative to positive, there is a point which is 0, and that is this horizontal line where the gradient is 0. From negative to positive, this is the transition. And if we consider this top point, the tangent on left of it would be negative. Sorry, that's positive. So positive and negative again. This is a horizontal line. The gradient at the turning point is 0. For example, we consider this question, find the least value of the following functions. Now he is already giving us that it is the least function. In our next exercise, the examiner will inquire and want us to find if the function is least function or greatest function. And the least value would mean that the curve is a smiley face. You can also tell this by looking at the coefficient of x square, which is actually positive. So the question is f of x is equals to x square minus 12x plus 8. So we're going for derivative. F dash of x is equals to 2x minus 12, and we know that at the turning point the gradient is 0. So we substitute 0 in place of gradient and solve for x. 12 is equals to 2x, x is equals to 6. Now we know that at the turning point the x coordinate is 6. The x coordinate is 6 and y coordinate is unknown. Now put this back in the original equation to find y. So f of 6 is equals to 6 square minus 12 into 6 plus 8. 36 minus 72 plus 8. Minus 36 and 8. Yes, Mark. Plus 8, I am finding the coordinate, y coordinate, in the main equation. For f dash x, that was a constant, so that is removed. But in the original equation, it stays there. So the turning point is 6 comma minus 28. Another question of the same difficulty level, 5x squared plus 2x. Exercise 12I, question number 1, C part. F of x is equals to 5x squared plus 2x. So f dash x would be 10x plus 2. We know that the turning point gradient is 0. So solving for x, minus 2 by 10 is equals to x, and x comes out to be negative 1 by 5. Now you know the x coordinate. For the y coordinate, we write the original equation again. F of x is equals to 5x square plus 2x, and use the value of x at the turning point. Five into 1 by 25 minus 2 by 5. So 1 by 5 minus 2 by 5 is minus 1 by 5. So turning point is minus 1 by 5 comma minus 1 by 5. Any confusion till now? Second question says find the greatest value of the following functions. Now this is actually a sad face, and you can see the coefficient of x square is negative. This will give you max value, this will give you minimum value, greatest or least. So find the greatest value of the following functions. Question 2a. F of x is equals to 10 minus 5x square. So we go for f dash x, because at the turning point we know the gradient, minus 10x. When gradient is 0, x is 0. So at x 0, f of 0 is equals to 10 minus 5 into 0 squared is 10. So x 0, y 10. This is the turning point, 0, 10. Question 3 says find the coordinate of the point where the gradient is 0. On the curves with the given equations, establish whether these points are local maximum points or local minimum points. Okay, what this local maxima and minima is? If you have few questions, for example, the curve looks like this. So in this case, we can say we have 1, 2, 3, and 4 turning points. But out of these 4, we know 2 are max and 2 are minimum points. Out of the maximum, the larger one, the higher one is local maximum, and out of the minimums, the lower one is local minimum. So if you have more than 2 points, so okay, let's solve first. Find the coordinates of the point where the gradient is 0 on the curves with the given equations. Establish whether these points are local maximum or local minimum points. If I start with question number 3a, we already know it is a quadratic equation, y is equals to 4x square plus 6x. So it will have only one turning point, that would be either minimum or maximum. In the case, we already know that this is positive, so dy by dx is 8x plus 6. At turning point, the gradient is 0. Finding x minus 6 by 8 is equals to x, so x is minus 3 by 4. So we know x, we can find y. 4x square plus 6x is 4 into minus 3 by 4 squared plus 6 into minus 3 by 4. And let me reach out for the calculator. Squared plus 6 into minus 3 divided by 4 minus 9 by 4. So this is minus 3 by 4 comma minus 9 by 4. Now we know that this is the turning point, and we know that this is local minimum. How do we know this? We get to know x by putting dy by dx equal to 0. We found x. How did we find y? We found this value of y by substituting the value of x in the given equation. But how do we know that it is minimum point? So this is the catch, that coefficient of x square is positive, and positive would mean that it is a smiley face. So this point is actually minimum. And through calculation, how do we do that? We go for double derivative. So I'm copying this dy by dx. So dy by dx is equals to 8x plus 6. Now I'll go for double derivative. Let me reopen this file. Dy by dx is equals to 8x plus 6. Now I'm going for double derivative. So d square y over dx square is equals to 8. So I'll state d square y over dx square is greater than 0. Positive means minimum. This is how we will show it, that if it is minimum or maximum point. Now if you look at, let's try one cubic, this C part. Question 3, part C. Equation says y is equals to x cube minus x square minus x plus 1. Now we know this is cubic. We should have two turning points. When we go for dy by dx, this is 3x square minus 2x minus 1. And we know that at the turning points, the gradient is equals to 0. So 0 is equals to 3x square minus 2x minus 1. Now we solve for values of x. I'm going for midterm breaking. So minus 3x plus x is equals to 0. Taking out common 3x, this is x minus 1 plus 1 x minus 1. So 3x plus 1 times x minus 1. First factor equals to 0. Second factor equals to 0. Next equals minus 1 by 3. And x is equals to 1. I've just drawn this sketch without considering anything. It could have been this way as well. But if you remember the sketching chapter number, I think that was 5. So we know that this is cubic function and the coefficient of x cube is positive. So this is the sketch we'll be looking at. But anyhow, we know that we have two turning points at x minus 1 by 3 and x1. If this is the number line, I know that x minus 1 by 3 at this point and at x is equals to 1 at this point, I am going to have the turning points. Now I can find the y coordinates and I can tell which one is maximum and minimum. So first, finding the y coordinates, copying the equation again, which is y is equals to x cube minus x square minus x plus 1. Copying the main equation to find the coordinates. So when the value of x is 1 by 3 cube minus 1 by 3 squared minus 1 by 3 plus 1, the value of y is cube minus 1 divided by 3 whole squared, 1 divided by 3. This is 32 by 27. One of the coordinate is minus 1 comma 3 comma 32 by 27. Is someone cross-checking this? Please do if you're not doing it. Just the calculator part. The remaining I'm confident it is correct. This is 32 by 27. And the other coordinate y is equals to at x1 cube minus 1 square minus 1 plus 1. Thank you. 1 cube is 1, square is 1, minus 1 plus 1. So minus plus con. This is 0. So the other coordinate is 1 comma 0. Now we know these are the two coordinates. Let me name them A and B for the ease of mentioning them. So if this is A and B, now I have to check which of the point 1 minus 1 minus 1 plus 1. Now I have to see out of A and B which is maximum and which is minimum. So we copy the derivative. dy by dx was already there, which is this 3x square minus 2x, 3x square minus 2x minus 1. So we have the derivative, and going for double derivative, d square y over dx square is 6x minus 2. Now I need to check if it is positive or negative at x 1 by 3, negative 1 by 3, and at x1 1 by 1. So when x is negative 1 by 3 minus 2 minus 2, it is negative 4. So I can say negative 1 by 3 comma 32 by 27 is, this is negative and negative means sad face, is a maximum point. Why it is maximum point? Because, or you can say the such as d square y over dx square is less than 0. Now checking for the second point. D square y over dx square is equals to 6x minus 2. Now the x coordinate at the second point is 1. So when we substitute 1, we know that it is positive. So 1 comma 0 is a minimum point, as d square y over dx square is greater than 0 or positive. Getting it? A quick summary. Y is equals to something, dy by dx is equals to 0. To find the two different turning points x coordinates. So we're done with x coordinates, we're done with x coordinate of both the points. When it is equal to 0, we find x. Then we put the x coordinate back in the equation to find the coordinates. We're done with y part as well. Now we know the turning point complete coordinates. For us to show that d square y over dx square, that is it maximum or minimum. So when d square y over dx square is positive, it is minimum. When it is negative, it is maximum. So this is the whole question. Y, dy by dx, coordinates, and double derivative. This was the equation. Y, dy by dx equal to 0. We get the x coordinates. We put this x coordinate back in the main equation to find y. Now we have the coordinates. After having the coordinates, we are moving to the next step to see if it is a minimum or maximum point. Any confusion till now? Okay. Now let's see what do we have in higher order questions. For example, this I part when the power is 4. Question 3, part I. Y is equals to x4 minus 12x square. We can change the course of the question, the order of question. We can find the coordinates at end as well because we didn't use y anywhere. So this is your choice, how you want to go about it. So dy by dx is equals to 4x cube minus 24x. Done with dy by dx. Gradient is 0 at the turning point, so 4x cube minus 24x. We're solving for x, dividing with 4 on both sides. 0 is equals to x cube minus 6x. Taking out common, this is x square minus 6 is equals to 0. First factor is equal to 0. Second factor is equals to 0. So we know that x is equals to 0 and x square is equals to 6, which would result in x is equals to square root 6 and x is equals to negative square root 6. So we have 3 values of x. On these 3 different values, we can find 3 different values for y. 12x square. So when it is 0, y is 0. So first coordinate is 0, 0. Just for the ease, I'm labeling them as A, B and C. Second, when it is square root 6, power 4 minus 12 square root 6 power 2. 6 square is 36 minus 12 into 6. So 36 minus 12 into 6 is negative 36. Second coordinate is square root 6 and negative 36. Third would also be same as the powers are even. So negative square root 6 will result in a positive value. Minus 12 negative square root 6 whole square will again result in a positive value, which is negative 36 again. So at negative x, this is negative 36. Step 1. Copied the question. Dy by dx equal to 0. Found the 3 values 1, 2, 3 values of x. Step 2. Substitute these values in the main equation to get the coordinates 1, 2 and 3. Now we know the coordinates, but we need to tell if A, B and C is maximum or minimum. So A, B and C, these coordinates are maximum or minimum. So what will we do? We'll copy dy by dx and go for double derivative. So dy by dx, copying this, which is 4x cube minus 24x. So when we go for double derivative, let me write it here. Dy by dx is 4x cube minus 24x. Now when you go for double derivative, d square y over dx square, double derivative is 12x square minus 24. Now I'm going to check for A, B and C one by one. When x is 0, this is negative. So d square y over dx square, when it is negative or when it is less than 0, it is a maximum point. So at x is equal to 0, d square y over dx square is less than 0. So that's a maximum point. This is max. Checking for the remaining points. D square y over dx square is equals to 12 into square root 6 whole square minus 24. 12 into 6 minus 24. 12 into 6 minus 24. Just a second, I'll be back. थोड़ी देर की क्लास है, रिकॉर्डेड है. 12 into 6 minus 24 is 48. Now when 48 is positive, and we can say d square y over dx square is greater than 0, so it is a minimum point. And we know that when you will substitute negative x square, it is actually a positive power. This will again give you the same answer. So this is also minimum. So we have two minimum points and one maximum point. If I need to sketch this, how will we do? Consider this a number line. 0 should lie here, positive square root 6, negative square root 6. And we know this is minimum, this is minimum, 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 and this is maximum. So this should look like this. Now I have the rough sketch. If I try to draw it a little neat, you will have this value 0, 0. That's not neat. This is x bar 4 graph. So 0, 0, positive square root 6, negative 36, and negative square root 6, negative 36. So these two are minimum points, and this is the maximum point. I'm just drawing sketches because we did this in chapter number 5. This was not the requirement of this question. Other than that, the question is complete before this graph. Just for the sake of concept. Sketch the curves with the equations in part. Okay. Question number 4 says sketch so indirectly. We did this question 4 as well. Not for every part, but yes. Look at question number 5. By considering the gradient on either sides of the stationary point on the curve, y is equals to this. Show that the point is a point of inflection. Sketch the curve this. Okay, now the demand of the question is different, that show this through this given path. For example, we solve this question. So question number 5 says y is equals to x cube minus 3x square plus 3x. By considering the gradient on either side, show that the stationary point. So first I'll find the stationary point. So dy by dx is equals to 3x square minus 6x plus 3. 0 is equals to 3x square minus 6x minus 3. Dividing the complete equation with 3, this becomes positive 3. You can do it with both. Positive 3, dividing on both sides with positive 3. We can do with both. I'll show you. Minus 2x plus 1. For example, if you take all of this equation on left hand side, you will change the signs. Final answer would be same. So let's try midterm breaking. This should be minus x plus 1 is equals to 0. Taking out common, x minus 1 x minus 1 is equals to 0. X minus 1 into x minus 1, and x is equals to 1. So at the turning point, x is 1. Our conventional method was that we go for d square y over dx square, but in this question particularly the examiner is asking you show that the point is a point of inflection by considering the gradient on either side. So by considering the gradient on either side, turning point is x is equals to 1. So gradient on either side, let me say on right hand side, let me choose 2. On left hand side, let me choose 0. 0 is to left of 1 and 2 is to right of 1. So I am looking for the gradient that dy by dx is equals to 3 into 0 squared minus 6 into 0 plus 3. When x is 0, I see that the gradient is positive. Gradient is positive on this side, so it is increasing function. And dy by dx is equals to, copying the equation, 3x square minus 6x plus 3 on right hand side of the turning point, which is this 2. You can choose any point, make sure you keep it simple. So 3 square, 2 square is 4, 3 times 12 minus 12 plus 3. This is 0 plus 3. So gradient on both sides is same. So this is proof that it is point of inflection. Did you get this part or not? For example, you have this thing. If I draw it this way, these are clearly 2 points. And if we draw the cubic curve like this, so at this point it is point of inflection where the gradient actually switched literally on the point, just on the point. Logically, cubic equation should have 2 turning points, but we got only x is equals to 1. And we know that at x is equal to 1, the gradient is 0. So this point should have a horizontal tangent. Getting it? Any question? Okay. Question number 6 says find the maximum value. Find the maximum value and hence the range of values. So 27 minus 2x4. Finding the maximum value and the range. Easiest way is to go for the derivative. Constant goes away, minus 4 2 times is 8x cube. At the turning point, gradient is 0, minus 8x cube. X cube is equals to 0, x is equals to 0. So at x is equals to 0, f of x is equals to 27 minus 2x4. 27 minus 2 into 0 power 4 is 27. So we know that the turning point is x, 0 and y, 27. Now is it minimum or maximum? So I'm going for double derivative. Copy f dash x, which is negative 8x cube. Solve for double derivative. This is negative 24x square. You substitute the turning point, you get 0. 0 is basically positive, so it is a smiley face. And we know that the lowest point is 27. So range is f of x is greater than and equal to 27. Any question? For example, if x was not 0, let us consider a random equation. Let's say whatever y was, and then we had f dash x or dy by dx something, and x turned out to be 2. This is what you are asking. If it was not 0, so when it is 2, you put that back, you will get x comma y. Agreed or not? So we're done with the coordinate, first thing. Second thing, we check for double derivative, d square y over dx square. use this, and now we have this double derivative as well. Done. When you have this double derivative, you put this x coordinate and see if it is positive or negative. Let's say it is negative. If it is negative, this would be a sad face. This point right here is x comma y. Now let me suppose these values. Let's say this is 2 comma minus 7. So your range would be that f of x is less than and equal to minus 7 at all times, because this is the highest value it can reach. All other values are below minus 7. Clear? It actually makes no difference whatever the value is, 0, 1, 2, anything. It is always y dy by dx d square y over dx square. So it makes no difference whatever value you use. Question number 7. Find the coordinate of stationary point. What would you do? Equation is given. How will you find the stationary point? That's right. To find the turning points. So first step is we go for derivative. And now what are we going to do? Find the stationary point, and we are going to tell the nature. So for the stationary point, derivative is equal to what? And we should substitute it with 0. Now we factorize the cubic factor to find the 3 values of x. Now first thing was hit and trial, remember? So just pick up your calculator and see at what value do you get 0. So I'm trying at 1 and luckily I got 0 at 1. So when x is equals to 1, 4 into 1 cube plus 9 into 1 squared minus 10 into 1 minus 3, and I am getting a 0. That would mean the first factor is x minus 1. And this was 4x cube plus 9x square minus 10x minus 3. Using x minus 1 for long division, multiplying it with 4x square to get 4x cube minus 1, this is minus 4x square. We change the signs and we add them. 13x square minus 10x minus 3. Second step, to get 13x square, I multiply it with 13x. This is 13x square. Minus 1 into 13 is negative 13x. We change the signs and we add them to get minus 7x. I'm multiplying it with negative 7. Sorry, 10 and 13 is 3. So this is minus 3. So we multiplied with minus 3 to get minus 3x plus 3. Then we change the signs and add them. So this cubic factor is now broken down into quadratic and linear. So plus 9x square minus 10x minus 3 would now look like this. X minus 1 into 4x square plus 13 minus 3. Yes. Now that's not negative, that's positive. We change the signs and then we add them. This point right here. That is negative 10 and positive 13. Now you have a linear and the other is quadratic. 4 3 times is 12, so 4x square. This should be positive and this should be negative. So 12 is either 12 into 1 or 2 into 6 or 4 into 3. Let me see if we have a factor. Minus b plus minus square root b square minus 4 into a into c over 2a. So we actually have, we don't have exact values for this. I'm using quadratic formula. With what? Hit and trial. Hit and trial for the first factor and then long division for the quadratic factor. So x minus 1 into 4x square plus 13x minus 3. So using this I got minus 13 plus, can you just double check this part, minus b plus minus square root b square minus 4ac over 2a, minus 13 plus square root b square minus 4a and c is minus 3 over 2a, minus 13 plus minus denominator is 16 minus 13 plus square root 13 square minus 4 into 4 into minus 3 over 2 into 4. This is 8 in the denominator. Can you please confirm if we have the same answer? So x is equals to 1 and x is equals to negative 13 plus square root 217 over 8 and x is equals to negative 13 minus 217 square root over 8. These are the three values. Now we can plug in these three values in the main equation to find the coordinates, and the remaining part would be to tell the nature. Then we go for double derivative and substitute the values of x. If it is positive, it is minimum point. If it is negative, it is a maximum point.